Hey guys, so today we are doing parallel and perpendicular lines. We're just adding on to our theorems that we have for this chapter. So first, you guys are going to be able to apply 3 new theorems related to parallel and perpendicular lines to either diagrams, word problems, and proofs. So our first task for today is to do a drawing. Now on your notes, you will have space to draw it. So the first thing you're going to do is draw line A, and I'm just going to draw it in this corner here really small so that you guys can kind of follow along with me. So if you draw line A and label it line A. Next would be to draw line B parallel to line A. Now obviously I'm doing this on the computer. It's not going to be perfect because the computer wobbles a little bit when you draw on it, but whatever. So if these are parallel, we can go ahead and write our little parallel symbols there, which are the arrows. Then the next step would be to label the parallel line. So we did that already, or I did that already. Make sure that is on your diagram there. Okay. The next step is to draw line C parallel to line B. So here's line C, and these two are parallel. So I'm going to do a different style here. So I'm going to do 2 tick marks instead to show that B is parallel to C. Okay. Now, we labeled the parallel lines. We already did that. So your picture should look like mine in the corner or the picture that is below. Obviously, if your lines aren't slanted, it's perfectly fine. So go ahead and make a conclusion on your paper, okay? Make a conclusion on your paper. Okay, drawing 2. Draw line M. Then draw line T perpendicular to line M. So here's line M, here's T, and draw it perpendicular. So we know that perpendicular means it has to make a 90-degree angle. So to do that, we just throw a 90-degree angle symbol in there to show that those 2 lines are perpendicular. Next step is to draw line N perpendicular to line T. Okay, so we labeled it perpendicular, and it should look like this, or it could look like mine in the top corner. That's fine. Doesn't matter which direction your lines are pointing. Doesn't matter if they're slanted or whatever. But I want you to make a conclusion about this one, about the lines. Just draw it somewhere in your box there. For drawing number 3, draw line L first. So I have line L. Draw line N perpendicular to line L. So here's N, and then it's perpendicular. We labeled them perpendicular with our right angle. Next step is to draw line M parallel to line L. M. And then we want to say that these 2 are, oh, I guess I maybe messed that up. Dang it. We want to say that these 2 are parallel. So we want little things there to show that they're parallel. Make a conclusion about what you think is true about these lines. Nothing is incorrect here. Whatever you put down, it's not going to be wrong because we're going to go over it here in a second. Okay. So theorem 3-8. If 2 lines are parallel to the same line, then they are parallel to each other. So what we just did in drawing number 1, we have A is parallel to B, B is parallel to C, which means that A has to be parallel to C. So all of them are parallel together. Make sure to get that written down on your notes. This part here. So whenever you have, 2 parallel lines and they're parallel to the same line together, then those 2 lines are parallel to each other. Theorem Theorem 3-9 is in a plane. If two lines are perpendicular to the same line, then they are parallel to each other. So we have M is perpendicular to T and N is perpendicular to T. So that means that M is parallel to N. Get that written down. This is the part that you need to fill in. And I would highly suggest you underline or circle this part here, because in a second or a couple minutes here, you'll figure out why that's important. Okay, so for Theorem 3-10, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Okay, so N is perpendicular to L, and L is parallel to M. That means that N has to be perpendicular to M. So you're writing this part down. Now, here's where I was talking about that in a plane is important. The theorem above and the theorem before uses the phrase in a plane. We need to consider a couple things. So on this diagram here, we have CE is parallel, or perpendicular rather, to AC, okay? Those two are perpendicular and it's shown by that little red box there. AC is parallel to BD, okay? But CE, this one, is not perpendicular to BD. Why? Because all three lines are not coplanar. CE and CA lie in one plane, and BD does not lie in the same plane with those. AC and BD do, but not CE and BD. So CE and BD would technically be skew. There will be a question on your homework like this that asks what is the relationship between a certain two lines. So you need to be able to explain what that relationship is. If they do not intersect and they do not lie in the same line or same plane, they can't be perpendicular. If they do not lie on the same plane and do not intersect, they cannot be parallel. The two theorems, 3-8 and 3-9, we don't have names for those, so we'll just refer to them as 3-8 and 3-9 for now. Okay, so if we look at all these pictures here, there are examples of parallel lines and perpendicular lines everywhere. This is just a little funny for you. Parallel lines have got so much in common, it's a shame they'll never meet, which parallel lines will never meet. Okay, so let's do some practice here. Main Street intersects Avenue A and Avenue B. Avenue A is parallel. So first of all, I'm going to read through the whole question and then go back and draw some pictures. So Avenue A is parallel to Avenue B. Avenue A is also perpendicular to Main Street. How are Avenue B and Main Street related? So I'm going to go ahead and write that first one. Main Street intersects Avenue A and Avenue B. Okay, so I can't really do anything there because it doesn't give me what kind of lines they are, but it says Avenue A is parallel to Avenue B. So this is A, this is B. You can just, draw it like that. That's fine. And these are parallel to each other. So I'm going to make my little tick marks there. Okay. Then it says Avenue A is also perpendicular to Main Street. So Avenue A is perpendicular to Main Street. And I'm going to draw in that little 90-degree angle there, and this is M, Main Street. How are Avenue B and Main Street related? So you want to think about how if A and B are parallel and M and A are perpendicular, technically, by using theorem 3-10, the perpendicular transversal theorem, Avenue B would also be perpendicular to Main Street because or by theorem 3-10, which states that if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other parallel line. The next one, in the diagram below, lines A, B, and C are coplanar, so that's important. They're coplanar, they're all on the same plane. What conclusion can you make about lines A and B? Okay, so if A is perpendicular to C and B is perpendicular to C, you could make the conclusion that A is parallel to B by the theorem 3-9, which means that if two lines are perpendicular to the same line, then they are parallel to each other. You could also bring this back to our theorems from Monday and Friday, or actually from Monday, Tuesday, and Thursday, Friday of last week. So you can think about what kind of angles are these two angles. Technically, they would be corresponding angles, right? So if their corresponding angles are congruent, we can use the theorem, the corresponding angles theorem, or the converse of it, and say that corresponding angles congruent would mean that we have parallel lines. Okay, so again, there's no correct way to get there. Obviously, for this certain problem, we have two ways. For number 3, so we're going to draw this. Draw the following. L is perpendicular to F. And obviously, this doesn't have to be perfect. If you want to use rulers, I do have rulers. Just ask me for one. So L is perpendicular to F. So for it to be perpendicular, you want to make sure that you draw in that 90-degree angle sign. Even though mine don't look like they're perpendicular because I suck at drawing and I'm doing this on a computer, just make sure you put that right angle symbol in there. Then it says now add P, so F is parallel to P. So this is P. Support your answer with what conclusion can you make about line L and line P? Support your answer with a theorem. So if L is perpendicular to F and F is parallel to P, that means that L is also perpendicular to P. And that is because of the perpendicular transversal theorem. So theorem 3-10. You might have wrote it like this or drew it like this one here, or you might have flip-flopped it and said, you know, L was this way, F was this way, and then you draw P over here. That's fine. Obviously, we're not all going to interpret this in the same way, and you're going to have a little bit of a different picture if you are just doing this on your own, okay? Number 4, or you guys try this one quick first. Pause the video and then we'll go over it. So a carpenter is building a trellis for vines to grow on. The completed trellis will have 2 sets of diagonal pieces of wood that overlap each other. So if pieces, for part A, if pieces A, B, and C must be parallel, what must be true of angles 1, 2, and 3? So pieces 1, 2, and 3 are parallel. And I'm going to draw in those symbols there just so it helps me out more. 1, 2, and 3. Angles 1, 2, and 3. So angle 1 is here, angle 2 is here, angle 3 is here. If all of those things are parallel, what could be true about those angles? Now, think back to multiple lines on a transversal. This line here would technically be our transversal, right? And then these other lines would extend out like this. So if we're thinking about this, angle 1 and 2 would be corresponding angles, and because they're parallel lines, they should be congruent. Angles 2 and 3 are corresponding angles, so they should be congruent. And any way that we put it, all three of those angles are going to be congruent because of those parallel lines. Okay, and that is because, I don't think I wrote it, or it's on here, but they're parallel. Because they're parallel lines, it means corresponding angles are congruent. Okay, and that I just put that down there so that you guys could understand the theorem there. Now for part B, the carpenter attaches piece D so that it is perpendicular to piece A. So I went ahead and drew a 90-degree angle here. It can be there or it can be here. It doesn't matter. Either way, it's perpendicular. So what would be true to pieces B and C? Is piece D actually perpendicular to those pieces as well? The answer would be yeah, D is perpendicular to B and D is perpendicular to C because of the theorem 3-10, or the perpendicular transversal theorem. If all of those, A, B, and C are all parallel lines, so if one line is perpendicular to A, it has to be perpendicular to B and C as well. Okay, so then if you turn your notes page over, there is your homework. You can work on that. It needs to be turned in on Canvas. Once it's complete, you just need to take a picture of the homework side. You don't need to take a picture of the note side. I'm going to give you some time in class to work on this, and then we will probably be starting on 3.5 as well today. Okay? Have a good day. See you guys later.